Okay. Good morning or afternoon or evening, depending on where you are in the world. My name is Carlton Doe. I am with IBM, and today we're going to be talking, this is the second of our three scheduled technical deep dives into the features and benefits and enhancements of the Informix 14.10.xC4 release. 2 weeks ago, there was a session on the CSDK and IHQ. Today we're going to talk about enhancements with the various replication technologies that are built into Informix. In 2 weeks, on August 26th, the third and final scheduled session will occur, and in that one we'll talk about Java as well as other enhancements to system administration, instance administration, and so forth. This session is being recorded. There will be a replay available as well as a PDF version of these slides. In your registration confirmation document, there was a link to a box file where this information will be uploaded a little bit later on today. The replay does use a proprietary WebEx video format, and you need to download and use their player. In the box folder, as well as in the registration confirmation, was the URL to the location of that player. So with that, let's go ahead and get started with replication enhancements. Oh, by the way, I should mention that Nagaraju from HCL Development is on the webcast. I believe he's monitoring the chat session. I will open this up for questions at the end of the presentation, but you can feel free to throw them into the chat. Nagaraju may or may not respond to them there, or we may just hold on to them and wait till the end of the session. But just be aware that we do have people from development on the call to help answer any questions that I can't get through. So anyway, here we go, replication enhancements. There are about 3 or 4 things we're going to talk about today. The first one has to do with an offline conversion support for HDR and RS secondaries where you want to make a major migration between different fix packs or even between different versions of the engine. There's a very nice enhancement here. It's still going to require an outage, but as you're going to see, it doesn't require reinitializing the secondaries, which is really, really nice. We'll talk about enhancements to smart trigger functionality. Those of you who participated in the session 2 weeks ago know that we talked about a few enhancements to smart triggers, specifically the ability to use the Python language now in conjunction with smart triggers. And this one will talk about survivability, what happens if your session disconnects or you have to go through an HA cluster failover. We'll talk about some changes and enhancements to the Cdr Migrate Server, particularly around referential constraints and improving data synchronization. And finally, just some improved statistics for RS and SD secondaries around flow control and what those statistics can provide to you. Okay, so let's start with offline conversion for HD and RS secondaries. Over time, the HA cluster has seen small incremental improvements in functionality till we got to the 11 time frame where there's this massive infusion of new technologies. We went from just having a single secondary to being able to have multiple different secondaries of different types. And with that, we've also been slowly migrating and enhancing how you can migrate between different Informix versions within the HA cluster. Now with ER or with GRID, when that came out with 11.7, it was fairly easy to migrate between versions of Informix because each node was independent. So you could take one down, rev the version of Informix, bring it back up, and life would just go on. HA cluster was a different story because it is literally a clone of the primary. The prevailing rule had always been that what you have on the primary, you must have on the secondary. So if you're on 12.10.xC3 on the primary, all of your secondaries had to be 12.10.xC3. Well, So how did we deal with that over time? How did we rev the HA cluster over time? Initially, when the cluster first came out and into the 11.10 and early 11.5 time frame, you only had one choice, and that was to take the entire cluster down, upgrade the primary, turn it back on, upgrade the secondaries, and then reinitialize them from scratch. Whether you used an on-tape or an on-bar restore process and then the appropriate on-mode commands, basically you had to rebuild the HA cluster from scratch. And that was painful. It was time-consuming, particularly if you had really large primary systems, to do an on-tape backup and then restore and so forth. At 11.7, we came out with some technology that allowed you to perform what I call inter-version upgrades. So let's say you wanted to go from 11.7 to 12, or you can still do this going from 11.7 to 14 if you wanted. And this process used flexible grid technology and a function called sec2er, which basically converted your HA cluster into an ER cluster, a grid type of a cluster. And with it in a grid cluster now, each of these secondaries were independent. Actually, all the nodes in the cluster were independent. So you could rev one to a different version of Informix, bring them all up to the same version. Then you had to go through a process of converting the primary, or converting what used to be the primary node from ER back to a primary, but then you had to reinitialize all of your HA secondaries. The advantage was, well, while you're doing this migration, at least you had full cluster capabilities for a short period of time. But it was still painful. It still required reinitializing the secondaries, and it just, you know, we were learning and growing as we went along. So now we fast forward to 12.10.xC5. In 12.10.xC5, we gave you the ability to have what we call rolling upgrade functionality within your secondaries to support intra-version upgrades. So you had to be within the same product family. In this case, it was 12.10.xC4 or higher. And it gave you the ability to move from one fix pack to the next sequential fix pack. So you could go from XC4 to XC5 or XC5 to XC6. But you could not jump straight from XC4 to XC6. And what this allowed us to do was take down the primary, upgrade to a new version of the instance. Excuse me, let me turn this off. Go to the new version of the binary, turn the primary back on, and the secondaries would still be in the cluster. Then you could take those down and upgrade them one at a time, bring them back up, and you could do this, like I said, XC4 to XC5 type of an upgrade, and you didn't have to reinitialize the secondaries. But as I said, you were limited to the next sequential fix pack. Well, what if you do need to make a major upgrade? What if you need to go from XC2 to XC6? You still had to take the secondaries offline, rebuild them, or convert the cluster to ER and go through that whole mechanism. It was just a pain. Well, in Informix 14.10.xC4, we now support what we call offline secondary conversion for HDR and RS secondary nodes. Now, you're still going to have to take all of the nodes offline at some point or another, but you're not going to have to rebuild the secondaries. Okay? So here's how it works. It allows you to support upgrading from 11.7.xC1 directly to 14.10.xC4 or later. So you can't go to 12, you can't go to 14.10.xC3, it has to be XC4. And by the way, this is a one-way conversion. So you're going to be able to go from 11 up to 14, but not from 14 back down to an earlier version if it doesn't work. Now, one of the things that we strongly, strongly, strongly recommend you do if you're going to use this type of offline conversion is to turn on the conversion guard functionality. If there's any type of problems during the upgrade process, it's going to be captured by conversion guard. You're going to be able to look and see what those problems were and go in and fix them. So what's the workflow? How do you perform one of these offline conversions? Number one, you want to disable failover control. Because one of the first things, well, the first thing you're going to do is convert the primary. And in that in that case, you don't want one of your secondaries flipping over and becoming the new primary inside the cluster. So you're going to disable failover control. You're going to go in and enable conversion guard on all of your instances, and then you will shut down the primary instance. Okay. Now, if you are using secondary instances in an updatable secondary type of functionality, reads on those secondaries will be able to continue. So all your queries and everything else will work fine. However, DML language, inserts, updates, deletes will be blocked. And it will be blocked immediately, because you'll say, yes, I want to commit this, this insert or this delete or update, and you'll immediately get an error back. So it's not as though the application will hang and you'll wonder what's going on. So the primary is down, conversion guard is turned on. If you haven't already done it, you install the new Informix binary, you check and make any on-config changes you need to make, and then you restart the primary. Now the primary will treat this just like in an online in-place migration. So it will go through all the upgrade processes that it needs to for maybe new sysmaster schemas, Cdr schemas, background changes that need to occur, even to system pages and so forth. But what's new is all of these changes are going to be captured in the logical logs. So, and I probably should have put this earlier, you want to make sure that your logical logs are free, that you've got enough free space, that they're being backed up properly, because all of that information is going to go into the logical logs. If this primary upgrade fails, bingo, here's where conversion guard comes in. You can play around with on restore report to figure out what broke, fixed it, and so forth, okay? By the way, as you're going through this in-place upgrade, whether it's on the primary or secondary, none of your end user sessions will be able to connect to the instance. It will be in an administrative type of mode. So nobody can get in until the instance is fully converted and online. Okay. So with the primary upgraded now, it knows about the secondaries. The secondaries know where the primary is. They will try to reconnect with each other, but the secondaries will not be able to reconnect because of the global version IDs that are inside the instance. That's part of what makes the rolling in-place upgrade work, is we check these global IDs inside the binaries and see, is it just one fixed backup or more than one fixed backup. In this case, it's going to be more than one fixed backup, so the secondaries will not be able to reconnect. They'll still think that the primary is offline. Again, queries will continue, DML won't. So now you take your first secondary offline. You install the new binary, you make the on-config changes, you turn that secondary on. It goes through the same in-place upgrade process as the primary. And if that fails, again, you use the on-restore checkpoint to figure out what broke. Once the conversion is complete, it will ping the primary and say, hey, I'm here. The primary will say, well, I'm at log sequence number whatever. The secondary will say, oh, I'm way behind, and the primary will send down to the secondary any internal changes that it needed to make so that the two instances are fully in sync. Once that upgrade process has been complete on that secondary, you want to do an on-mode -C to force a cluster-wide checkpoint. So both instances are on the same checkpoint timestamp, and we know that one doesn't have committed transactions that the other doesn't. And that secondary is now online, operational, and you didn't have to reinitialize it. It will reconnect to the primary, reassume its role as either an HDR or an RS secondary, and off it goes. And you will do this for every single one of your secondaries, with the exception of the shared disk secondary, which we'll talk about in a second. Once all of your HDR and RS secondaries are up and operational, then you turn failover control back on, and congratulations, you've upgraded the cluster, and you didn't have a major upgrade to the cluster, and you didn't have to reinitialize the secondaries. But what happens if you do have a shared disk secondary? Workflow is exactly the same. However, the very first thing you do is you turn off the SD secondary or SD secondaries. You go through, you promote you turn off failover control, you promote the primary, you promote all your other secondaries. Once those are all up and running, you go back to the shared disk secondary, install the binary, make any on-config changes, turn that one back on. And because it's using the same disk as the primary, it's not going to go through any conversion changes, and it just pops back into the cluster, and life is great. So that is offline conversion of HDR and RS secondaries. I think it's a great feature, one that we've been working towards, or I should say Nagaraju and his team have been working towards, and my hat goes off to them. Like I said, if you have any questions, go ahead, throw them in the chat, but we're going to continue on. Next is Smart Trigger Survival Enhancements. So last time, in the previous presentation when we were talking about the previous webcast when we were talking about the CSDK, I mentioned that smart triggers were introduced in 12.10.xC9, and they're used to work around what I call the ping problem, where an application needs to know, has data changed inside the database, and do I need to do anything with that data? And in the past, historically, that meant the application would have to ping the instance every X number of seconds and say, did this happen, did this happen, did this happen? And it just caused the requirement, the workload overhead on the instance was just too much if you had a lot of these pings going on. So using Java and JDBC, you can create a smart trigger, which is an ER replicate type of functionality that monitors for changes. And when those changes occur, it triggers the Java application to signal the other application that needs to know, the consuming application, that a change has occurred, and then that smart trigger that application can go off and do whatever it needed to do. Since 12.10.xC10, we've continued to make small incremental enhancements over time, including support for receiving events after an application reconnects to the instance. So let's say the application dies and it comes back up. We can now signal that application that, hey, you missed all this stuff while you were gone. Also in 14.10.xC4, we've now publicly published support for Python language with smart triggers, so you're not limited to just Java and JDBC. Now, the original design for smart triggers was for single instance functionality and single session. And the original design for smart triggers didn't take into account an instance failover. So let's say your primary dies and you now move to another instance as primary. What happened to the smart triggers? Or what happens if your session disconnected and then reconnected? Well, the original design said all this smart trigger functionality is going to be in instance memory, specifically connected to the session. So if the server goes down, you lose that shared memory. If the session closes, you use the session shared memory, and the smart trigger cleared and it was dead. We've realized since then that smart trigger use is becoming extremely popular, and real life happens. These triggers have to be able to survive what I call bad things happening, whether it's a primary failure or a session reconnect. So what we have done in XC4, or what Nagaraju has done, I should say, is enabled what we call survivability of smart triggers. And we are now going to be persisting some session and event data in the Cdr database so that you can read this even if we have to flip over to another instance. So what we call smart trigger session or server survivability requires a new session designator when you turn on your smart trigger, and it's a flag called Detachable. And to designate a session as detachable, you have to run this particular function in your session. And by the way, don't try this in DB Access. It doesn't work. It has to be either in a Java application or Python or something. And so you have to run this push data set detach function, or you have to execute that function. And what it will return is a unique ID. And Nagaraju may have a name for it. In the context of this particular presentation, I'm going to call it a Cdr session ID. It's not the instance ID for that session, but it is a unique identifier. And you need to and all the smart trigger functionality for that session is going to be tied to that session ID. And what you need to do within the application is capture that ID, because that's what you're going to use when you want to survive some sort of a failure. So once a session has been declared as detachable, you can view information about that session and what it's doing in two tables, the push data client and the push data event tables or views. If you want to look at all of the events, you can do an onstat -g PD and then the event keyword, or if you want to look at information for a particular session, that CDR session ID, you can do the onstat -g PD, CDR session ID, and event. If your client dies and then it reattaches or there is a server failover, that ID is what's going to be used for the application to reconnect to the instance and look and see what has happened either while I was disconnected or just reconnect to the new primary and continue processing operations through the smart trigger. If your session, if your client session physically disconnects from the instance and you create a new session and you reconnect to the instance, you can adopt that original session ID. You have to know what it is, which is why your application needs to capture it and somehow persist it somewhere. And so you would do a push data join what that old session ID was, and you will get another session ID, but it doesn't create a new one. It simply returns a smart blob descriptor where you can go in and look at what happened in the original iteration of the smart trigger functionality. So in the event of a failover, you can just restart on your own and continue forward, or if you want, you can go back in time and see what events might have been in flight when the failover occurred, let's say, or you disconnected, and then reprocess those. Now, this is a manual process, and you will be responsible for handling any duplication of events that might actually have been processed, but then you go through and try and run it again. Well, how do you know where you're supposed to go back to? Well, we're giving you new information now in the context of what's returned with a session commit. Inside of the session commit now, or the return document, is going to be formatted in JSON, and there's two new fields which represent where within the logical logs did this transaction occur. So in this particular case, it was in log 31, position 24. So again, as you go through and you do a commit for this, that, or the other thing, if you want, you can persist that information someplace just in case you want to replay. You can look at that log file and say, oh, okay, the last transaction that I successfully processed was here. Did any other events occur that I need to go recapture? And that's, like I said, that's up to you to do. And this is the command where you can go in and look at those events. And what this will do is the Snoopy will go back through and look at the logical log records from that logical ID and that logical log ID and that logical log position and present the information to you. Obviously, this is only to be executed by the instance administrator, and this will be outside of a regular smart trigger session. So you want to do this as discrete operations through DB access or something like that. If you want to delete session ID or detachable session information from the instances, you can delete your current session. You can delete another session ID if you have it, or you can delete all of the sessions. And these are the syntax on how to do that. So depending on what you need to do, you run the appropriate command. So like everybody, let's see this thing in action. And I will state right up front, I have no clue how to use Java. I have no clue how to use Python. I can just create table statements, and that's about it, because I'm a bear of very little brain. But what Nagaraju has done is put in the Informix demo CDC directory a a couple of ESQLC programs where you can play with this on your own. So with his help and him guiding me through this, I compiled the ESQLC program, and then I ran it. So it's this push data application. And I went in and I started the application. I said, here's the smart trigger that I want to invoke, which is basically select anything that happens to the customer full table. And you can see that in the context of that application, it went out and did the registering the session as a detachable session and everything else. So it gave me what my CDR session ID is. And then I did the same thing for another table as well. So now I go in. So here's the REPL that supports the smart trigger on that customer full table. So I go in just as an end user in another DB access session, and I make two changes to that table. The first change is I changed his last name from Ludwig to Lewis, and then I changed his name from Polly to Patrick. Inside of that push data application now, it was giving me the transaction information that is being returned to it. And so you can see that it occurred in logical log number 44 at this particular location. So it's giving me now these logical log IDs or logical log positions that I might need to replay if a failure occurs. Well, let's see what information is available about it. So I do the onset minus GPD event. You can see there's my unique session ID of 2. There has been so far 1 event condition. Here's what the smart trigger is built on. It's on the customer full table. Gives you what the replicate name is if you want to go and investigate that. So this is the background metadata now on this smart trigger. You can obviously go and look at it just from a session perspective. So in this particular case, I display all of my sessions. I see, yeah, I think it's session ID 317 that I'm interested in. So I can deep dive into that again and look at the same information. So after several tests with this, I had multiple DB access windows open with different queries going on. And then I just killed the DB access session. So you can see now I've got all of these different REPLs out there for each one of the DB access sessions. But let's say I no longer want to have the smart trigger active. So in this particular case, I've got only 2 listed. I can go in and say, hey, I want to disable CDR session ID number 6. So I can do the push data delete, session ID 6, and now when I look at all the list of REPLs, one of them is gone because that smart trigger is now closed. Or you can go in and say, no, let's get rid of all of these. And so I can do a push data delete, delete all, and now all the replicates are gone because all the smart triggers are closed. So depending on what you need to do, you can invoke the proper command. And that is smart trigger survival enhancements. Now we get to Cdr Migrate Server, and there's 2 different pieces here, both more or less revolving around referential constraints and what we do with referential constraints. So just a little bit of background. Cdr Migrate Server was introduced with version 14.10.xC4. What it does behind the background is it configures and starts enterprise replication to do a heterogeneous instance migration. So let's say you need to migrate from AIX to Linux or Windows to some other platform. Yes, you could unload the data to ASCII, do a DB export, DB import. It's much, much faster to use Cdr Migrate Server. Since it's ER, you have a lot of granularity in terms of what gets replicated. Unlike the HA cluster, which replicates at an instance level, Migrate Server operates at a database level. So you could have 20 databases in the instance, but only want to migrate one of them, you can do it. Unlike IFX clone or so forth, which grabs everything. Now in XC3, 14.10.xC3, there was an option that was added that says, yes, I want to migrate database 1, but I don't want to migrate this table, and this table. So again, more enhancements, more granularity on what you actually replicate. And this, the Cdr Migrate Server does work from moving from Informix 11.7 on up. Now, as I mentioned last time, it does not support code set conversions. So if you want to go from to either to or from UTF-8 from another locale, you cannot do that. It's just going to, I don't want to say clone your instance, but it's just going to copy your instance. Okay. So Migrate Server works in a phased approach. There are multiple phases to this, each one doing a specific subset of functionality of the migration process. And the other thing is, these phases can be executed either in an execute mode where it actually does the work, or a non-execute mode where it builds a text file and says, this is what I would do if you let me go wild and actually run this. And what's nice is you can take that text file, make any modifications you want to it, and then just run it manually if you'd like. So for example, in some cases, maybe you want to change the placement of tables within a DB space or the sizing of tables. You could run that phase, just output the flat file, make whatever changes you want, then run the flat file so that your target has the new configuration the way you would like. And what's nice about Migrate Server is, as it goes through all the phases, it will look to see, has this phase already been done? So one of the phases is the creation of DB spaces to support ER. So it will look at onConfig to see if those spaces are configured. Then it will look at the instance to see if those spaces actually exist. If they do, it skips the phase and moves on. So it's really intelligent that way. So Migrate Server can operate in one of two different modes, either offline or online, or what is referred to as static and dynamic in the manuals. So in static mode, or offline, the source instance is blocked, and we just grab the data and shove it over there. You don't need to worry about any referential constraint violations because your source instance is stable. But if that's not possible for you, if your source instance needs to stay up and running while you migrate, there is a dynamic mode or an online migration where we will go through and migrate the data and so forth. And this is where it's possible to run into referential constraint violations when we get into the data migration phase, because we may be deleting child rows and parent rows, or adding parent rows and child rows, and at the moment we do the migration phase, we might be partway through a transaction, and so we grab the data as it exists, shove it over, but now we're running into issues on the copy. So what did we do or how did we handle this? Well, in XC3 and earlier, so at least up until now, there were a couple of different steps to what the data loading process was. One, the first part, we would take the table or the database schema, shove it over on the target, and rebuild it. The indexes, primary keys, and constraints were not created. So these were more or less just raw tables that we shoved over there. Then we went through and loaded the data, and depending on what option you told us, we could fork off multiple parallel load jobs. And what we used behind the scenes was the insert into select functionality that was released in 14.10.xC1. Once the tables were loaded with data, then we'd reapply the indexes, PKs, constraints, and so forth. And then we would check the referential constraints. Did they match? Did they not? Then we try and run a data sync phase to get everything synced up, but there was always this possibility for referential constraint to fail. So what we have now in XC4 is a new phase. Create schema, load data, no referential constraint. And what this does is it stops the building of referential constraints during dynamic migrations. Now you can, and the add RI phase has been added as well. that you would run after the data sync phase of a dynamic migration. And what these two do in combination is help resolve data sync and RI problems from occurring in these dynamic migrations. So again, nice piece of functionality. Again, something you want to test and understand fully, but you know, kudos to Nagaraju and the team for getting this done. So that's that piece of functionality. Now, continuing on, we've added, there's another new phase to Migrate Server called Add REPL Check. Now, this is optional. You don't have to put this in, and it's really up to you what you would like to do. If you are going to use this, I strongly encourage you to put it on the source instance first and then add it to any of your targets. Now, if your target is new or it's empty and you're going to be running a data sync operation on it, you don't need this REPL check. It's only for environments where you're going to be doing a data sync after the instance has been built. Because what we're going to do is add this shadow column that's a big int to the table, and it's going to have a type of a globally unique ID to it. And what we're going to do is check these GUIDs on the target and the source and see, is this the same version of the row on both sides? If it's not, then we're going to refresh the row. Now, because we're adding a shadow column, this is a slow alter. So just be aware, if you're going to put this on your primary, it's going to require an outage on each table as you run this functionality on. Okay. So what the value is inside of this REPL check column will vary depending on whether the insert into the target is a new row or if it is a modification of an existing row. In some cases, it's going to have a checksum of what the source row's values are. In other cases, it's going to have a version number type of functionality to it. Regardless, inside that number is going to be some information about which server in the server group it is. And that information is what's defined in SQL host. So where you have the group ID and the group number for that particular instance, that group number gets incorporated into this REPL check column value. Okay. So there is also an index that gets built on these tables that will have the shadow column as well as whatever columns or are used to determine uniqueness, whether it's a primary key, a unique index, or ER keys. Now, there's no options. You have no control how this index is built. But as I said, you can run the build database command, having already run this build REPL check. You can see where the index is going to be built. You can modify it to add a first size, next size, in DB space, whatever it is you want to do, and then go ahead and execute that phase manually. So again, why would you want to add this REPL check column? Well, it dramatically increases the performance of the sync data phase because we're not having to transport rows back and forth. We're just checking the GUID values. If they're different, then we know we need to push that row. If the value is the same, we don't push it. So here we go. I have two tables in the instance. I have one that's called customer empty, and I also have another table called customer full. As the name implies, one customer table is empty, the other one has values in it. And there is a primary key attached to each column, or to each table, excuse me. So now I want to migrate this database with these two tables from instance 1 to instance 6. But the very first thing I do is apply the REPL check phase. So this is me doing that. So you can see I'm doing a Cdr Migrate Server. My source instance is instance 1. My target instance is instance 6. What phase do I want to execute? The add REPL check. What database do I want to apply this to? The my test database. I'm giving it the ---- exec flag, which says go and do. And you can see here what the commands are that it went out and executed. So you can see that it altered the table and it added those REPL check columns, and then it also created this unique ID, or this unique index on with the GUID and the customer number, which is what is in my primary key. So now then, if I want to, I can go ahead and do a DB schema on the table, and you can see now there's a new qualifier to the table. It's called with REPL check, and you can also see the schema of the new index that's being created. If you want to look at this within the IHQ graphical tool, again, you can bring up the table. You can see that the IFX REPL check column is there. You can also see that it is a shadow column because it's got the little red X in that last column. And so, yes, it's there. And by the way, we talked about IHQ in the previous session. There's just great, great functionality in the Schema Manager component of IHQ with the XC4 release. So now we look at the shadow columns, okay? Obviously, there's nothing in the empty table, but I look at the full table now, and I can see that it has these different column values in there. What does it mean? I don't know. They're not user-friendly. We don't really anticipate you using them for much of anything. So now I insert a single row into the empty table, and I look at its REPL check value. And you can see it has, you know, this type of a checksum information. And then I update it with some new information. I changed the last name to Paulson and the first name to Lewis. And you can see that the version number has changed on the row, but still the root of the row, 68424, actually goes just to 6842. That's most likely information related to the Cdr server ID. But I don't know because I don't know what the magic is behind it. So anyway, that's the new add REPL check column or add REPL check phase for Cdr Migrate Server. Finally, the last thing we're going to talk about is some flow control statistics that are available on RS and SD secondaries. And as you'll see, this is to help you understand if you're having transaction throughput problems, is it because flow control is getting in the way? So flow control for RS secondaries was introduced in 11.5, and flow control for shared disk secondaries was introduced in 11.7. And it was introduced to help these secondary types stay current with the primary. Even though, for example, RS secondaries were using asynchronous communication, as you saw when I did the 14.10.xC1 release, it was possible for an RS secondary to fall farther and farther and farther behind in the primary, farther and farther behind what the primary was doing. And in turn, the RS secondary could reach out to the primary and say, hey, slow down so I could catch up. Same thing with the shared disk secondary. Hey, slow down so I can catch up. Even though it's using the same disk, there still needed to be transaction and other metadata updated inside the shared disk secondary. So it was possible for these secondaries to slow down the instance primary. That's what I call not a good thing to have happen. Now, and this could occur because you were using a carrier pigeon, let's say, for your transport mechanism, and it just took 4 days and and 3 hours for a message to get from A to B. The farther and farther behind these secondaries became, the less useful they were if you needed to fail over to them. You would lose too many transactions if they became the primary. But we didn't have any way of, at least up until then, any way of keeping these secondaries somewhat in sync or somewhat close to where the primary was, other than just throttling the primary. Now, at the end of 12.10 for the HDR secondary and in XC1 of 14.10 for the RS secondaries, you'll remember they completely rewrote the apply mechanism for logical log applies on these secondaries, and it is just wicked fast. I mean, just wicked, wicked, wicked fast. So we don't really anticipate having flow control problems anymore unless, of course, you're using the carrier pigeon and it takes 4 months, 3 weeks, and 12 hours for your transaction to get from A to B. Regardless, we are giving you the ability to look at statistics for flow control within the instance. So there's now an onstat flag minus G, RSS, verbose that has the flow control stats in it. And you can see it right here down at the bottom. You can see since the instance was started, there were a total of 14 delays, and the last time the delay occurred was at this particular timestamp. Now, this is looking at the shared disk secondary. I can do the same thing looking at an RS secondary. Lo and behold, same number of delays, same timestamp. So if you're having problems, and you're not sure whether it's the instance, whether it's the transport layer, what it might be, here you can look and see, did the secondary try and throttle the primary? And in this particular case, yes, it did 14 times. And then you can go and investigate why. And that is all I have for you today. As I mentioned, the registration information, registration confirmation had information on where to get the replay. But what I want to do right now is open this up for questions, which means I am going to be unmuting your lines. So if you'd be kind enough to mute yours so we don't get a whole slew of background noise here, we will open it up for questions. And are there any questions?
Wow. Let me type in music.
Again, can you mute your phone unless you have a question you'd like to ask? No questions? No questions?
Não, já não, caralho. Puta que
Going on? Hold on just a sec. Okay, I've just muted everybody. There are a number of people that have their phone off mute and there's conversations going on in the background. Can you please mute your phone unless you are going to be asking a question? So I'll give everybody a chance to do that, and now I will unmute everybody. There's that person. Okay. So going one more time, are there any questions?
No.
Yes? Okay. Hearing no questions, I'm going to go ahead and stop the recording.